Hello everyone, welcome to 1045 Engineering. We are here with yet another video in our mastering data structures and algorithms in Java, and today's topic is bubble sort. So let's get started. Okay, for bubble sort, you should understand that bubble sort is the simplest sorting algorithm. It's the most easiest one. It is very commonly taught when we are working with sorting techniques and algorithms. By working principle, this algorithm gets its name because the smaller elements bubble to the top beginning of the list and the larger element sinks to the bottom with each pass through the list. So with this, let's start understanding bubble sort. Okay. Now before we go on and understand, let me take an example for us. Okay. Let's say our input to us is given as 64, 34, 25, 12, 22, 11 and 90. Okay. Now first let me explain why it is called bubble sort, because we compare the two elements and the smaller element will bubble up and go to the start of the line. On the other hand, the bigger element will go to its correct position, that is the end of the line. Okay. So if you have to remember bubble sort, since there are a lot of sorting algorithms, always remember bubble sort is the one with comparisons, where we compare in pairs of two, first these two, then these two, then these two, these two, these two, this way. Okay. So now let's start. How do we perform bubble sort? Okay, this is our input, we know. Okay, and we know our output should be which is the smallest one, 11, then 12, 22, 25, 34, 64 and 90. This is the output we want to reach. Okay, so let's follow the steps and complete our bubble sort. Okay, so we have 4 steps in this, actually only 3, fourth one is just for optimization. Let's go through them. So first is pass through the list. So start at the beginning of the array, compare the first two elements. If the first is greater than the second element, swap them. Okay, so we start with the first, these two elements. First is bigger than the second element, so we need to swap them. So in next turn it became, we swapped them, it becomes 34, 64, 25, 12, 22, 11, 90, right? Let's go to second step. Second, continue comparing. So we have to continue this comparing, move to the next pair and repeat the same process. Now pay attention to this, move to the next pair. Okay, and repeat the process until the end of the array is reached. Okay, so next pair is these two. So I'm not comparing 64. Okay, I'm just comparing first two element, then next two element, then next two element, next two elements. Now 64 moved up, but let's say if it was a smaller element, instead of 64 here it was 24. So 24 comparison to 34 wouldn't have moved, and we would have been comparing 34 and 25. But 64 came here, so 64 and 25 will be compared, and in the next one we will have 34. 64 is bigger, so 25, 64, 12 and then rest of the elements. Similarly, we have to do it till we reach the end of the array. So next comparison would be of these two elements. Again 64 is bigger, so it will move, so it will be same area here, 25, 12, 64, 22 and rest of the elements. Next these two elements will be compared. So if you see, we first compared these two elements, then these two elements, then these two elements, then these two, then these two, and then these two will be compared. Okay, now 64 into 64 and 22 is compared. Again 64 gets moved, so we swap these elements. So 22 comes here, 64 comes here, and after 22 we have 11 and 90. Again in the next line these two elements are compared, we move 11, 64, 90. In the last one these two elements are compared, 64 and 90. Since 64 is smaller than 90, swap does not happen, so the end output is 34, 25, 12, 22, 11, 64, 90. Okay, so 64 came at its correct position. Okay, now repeat the passes. After each pass, the largest element in the unsorted portion of the array is placed at its correct position. Okay, so you have to understand it like this, that this complete process was pass 1, and after the end of pass 1, this element, the first element, reached its correct position, right? So let's start with pass 2. Now what will happen? Pass 2. So if you see, there is a for loop which we are running from I to n, where we are comparing I and I plus 1 element, right? This element and the next element, then this element and next element, this element and next element, right? So it's a for loop. But now this is only one pass. So we have to make more passes to do the same comparison throughout again and again until the complete array is sorted. As of now, only this portion is sorted, right? So it'll be another for loop. So a for loop outside this for loop, right? So now we'll go for pass 2. Now we have 34, 25, 12, 22, 11, 64, 90. So what will happen? We'll start with 34, right? These two comparison will happen. So next line it will be 25, 34, 12, 22, 11, 64, 90. Okay, now these two will be compared. 34 is bigger than 12 again, so it will move 12, 34, 22, rest of the element. Next turn, 34 and 22 are compared, so 22 this side, 34 and rest of the element. So let's mention 11 here. Now these two are compared, so we get 11, 34, 64, 90. Now these two elements are compared, but no swap happens. Next one, you can actually compare these two again, but no swap happens, or in the code you can stop this would be part of the optimization. But after pass 2, our elements look something like this: 25, 12, 22, 11, 34, 64, 90, and the array is sorted up till here from this direction: 34, 64, 90. These are sorted, these are still unsorted, right? So now we'll go for another pass, that is third pass. So we have to do it until the complete row of elements is sorted, right? So let's see if I can go down here. Oh, okay, nice. So I'll say pass 3. We have the input 25, 12, 22, 11, 34, 64, 90. So after the end of pass 2, this was the result. So after the end of pass 3, the result will be this should reach its correct position. So 25 and 12 will be compared, then 12 and first two, these two will be compared, then these two, then these two, these two, these two, and then these two. Of course, this comparison we can avoid, because since this portion is already sorted, right? Okay. Now, so after end of third pass, our result will look something like this: 12, 22, 11, 25, 34, 64, 90. Now comes a peculiar case. Okay, this is our pass 3. Now we enter pass 4. What will happen? Our input would be at this position. We are at 12, 22, 11, 25, 34, 64, 90. So we are sorted till here, right? So we compare these two. Bubble sort starts again. 12 and 22 are compared, but 12 is already smaller than 22. So what should happen? Should 12 move? Now let's go back to the step. If you see, move to the next pair and repeat the process until the end of the array. No, start at the beginning of the, compare the first two elements. If the first is greater than the second, swap them. But what if it is not greater than? Then do nothing. Move to the next pair. Okay, so we move to the next pair. 12 and 22 didn't, so no swap will happen since 12 is already smaller than 22. So 22 and 11 are compared, and then they swap. So after fourth pass, it will become 12, 11, 22, 25, 34, 64, 90. Then after pass 5, it will become, again we'll start the swapping again. As of now, it is sorted till here. We'll swap them. So it will be 11, 12, 22, 25, 34, 64, 90. So in 5 passes we completed this sorting. Now actually after this element again, the last element should be checked, but you already know by this time if the rest of the elements are in sorted manner, the last element will already be sorted, right? So this is the process for sorting, bubble sort in bubble sort. So to remember, always remember that we do passes one after the other. We take one pass, we compare one pair, the next pair, the next pair, the next pair, the next pair, and this complete comparison till the first element reaches its correct position will be called first pass, and then the same procedure will be repeated again until we reach the end of our solution. Okay, now let's go to the fourth step, optimization. The algorithm can be optimizing by noticing that the last elements are already sorted after each pass, so the subsequent pass does not need to check those elements. Okay, that is correct. You see, when we are doing when we are here at pass 3, and we know that these elements after the end of pass 3, 25, 35, 64, 90 are already sorted, but if you do not eliminate it in the algorithm, this comparison will happen but no swapping, this comparison will happen but no swapping, this comparison will happen but no swapping, these two, these two, these two, right? But no swapping will happen. But since no swapping is required, since it is already sorted, we can actually end our request here. If you see, this number of elements always increases with the passes, so we'll use that into factor. Okay, so let's code this now. Okay, I'll create a class, new Java class, let's call it bubble sort. Okay, now what all do we need? We need a main method and a sorting method, right? So let's create a main method first. Public static void main string args, okay, int array. What are our inputs? 64, 34, 25, 12, 22, 11, 19. 64, 34. Okay, so we'll say 64, 34, 12, 22, 11, 90. Okay, 1 2 3 4 5 6 25, 25, 12, 22, 11, 90. Okay, we have our input array. We'll call our method bubble sort. We'll pass our array, it will sort our array. No, not array 0, but just array. And once it's sorted, the system.out.println sorted array, and then let's go to next line. We'll print our array from array. I'll say system.out.println I plus, okay. So this way we'll print out all our elements from the sorted loop. Now our main method is done. Let's write our bubble sort method. So we'll say, or not inside this, or let me call it element. Let's call it element to remove the confusion. Okay, let's create our bubble sort method. So we'll say public static, we don't need to return anything, void bubble sort. We'll take the input array. Okay, so as of this stage we have these elements. You know what we have to do? We have to pass through these elements, we have to swap, we have to create passes for one swap, the next swap, the next swap, the next swap, and then there have to be multiple swaps, right? So let's do int n is equal to array dot length. Okay, let's start. For int I is equal to 0. I will start from 0. I is less than n minus 1. Why n minus 1? Because we are doing swaps. We are already doing less than n. We are doing swaps. So the I will reach till 11 only. Okay. So 11 and 90 will be taken in one comparison. If we go to 90, we don't take the next comparison. So this is already n minus 1 and less than n minus 1. Okay. So I is equal to 0. I is less than n minus 1. I plus plus. Okay. Now there are two for loops, right? So we need the second for loop as well. This for loop is going to be the outer for loop for the passes. I'll call them for passes, and we'll create one more for. Now in this one, int j is equal to 0. We'll start from this beginning. So this is the loop. Please understand, this is inner loop is the one that is actually performing this function. The outer loop is performing how many passes are going to run. Okay. So what do we need? For j is equal to 0, j should be less than n minus 1, right? J plus plus. Okay. Now if j is less than n minus 1, that means j will go till n minus so 1 2 3 4 5 6 7, so n is equal to 7. Indexing starts with 0, so this element is at index 6, right? So I can should be less than n, right? So I reaches till 6. But since we are already doing swaps, we are doing the comparison in pair, we the I has to reach only till this value. So we do I less than n minus 1. So I is always less than 6. I can only reach till the value 5. Okay. But after each pass, we noticed that the array gets sorted and we don't have to go and compare the last sorted elements as well, right? So we have the outer index I, that is for the passes, and the inner index is j, that is we are using for the traversal, right? So it should be less than I n minus 1 minus I. In the beginning, I is equal to 0, so it goes till 5. After in the second pass, let's go. In the second pass, here in pass 2, I is equal to 1. So we only need to go till I is less than j is less than n minus 1 minus I. So n minus 1 would be 7 minus 1 6, less than means 5, minus 1 4. So 0 1 2 3 4 will only go till 34, right? We are not going next. 0 1 2 3 4, only till 34. After this one, because this is happening because 90 was already sorted. Okay. After this one, in the next pass we'll only go till 25, then we will go only till 22, then we'll go only till 12, right? This way. So this is the optimization that we are doing, that we do not compare, and we do not waste our time in comparing the last sorted elements, since no swap will take place. Okay. So we do where are we? Yeah, for j is equal to 0, j less than n minus 1, and then minus I, right? J less than n minus 1 minus I, j plus plus. Okay. Now j plus plus, bracket close. Okay. Now what will we do? We'll compare and swap. That's all. So if array of j is greater than the next element, array of j plus 1, right? If you see, we are j is the index, so I is for the passes, j is the index that is running from here till here, right? So we are comparing j, array of j, and array of j plus 1, right? Next time we'll be comparing array of j and array of j plus 1, then these two, then these two, then these two, then these two, like this, from the indexing perspective. Okay. So if array of j is greater than array of j plus 1, that means we should swap. So we'll say swap array of j and array of j plus 1. Oops, plus 1. Okay. So we'll say int temp is equal to array of j. I'm just writing a swapping logic. Array of j is equal to array of j plus 1, and then array of j plus 1 is equal to temp, right? That's all. I think that is all that we need in this method. Let's run it. We can see I shouldn't have written and ln. Okay, let's run it again. We see 11, 12, 22, 30, 25, 34, 64, 90. They're already working. Now, there could be a case, okay, there could be a case, let's say, let's understand it here, that we are given an input something like 1, 2, 3, 4, 5, 6. And if we perform our swapping, this bubble sort right now with our current logic, we are going to compare these two, but no swap. Then these two comparisons will not happen because no swap. These two comparisons will happen. Then these two will be compared. Then these two. Then these two. In the first pass. In second pass, we'll compare only till here. Third pass will compare only till here. Fourth pass will compare only till here. Okay. But why are we even comparing if this is already sorted, right? So there should be a way where we can detect that if in this complete one cycle we did not make even one single swap, that means the array is already sorted. Or maybe the input was 7, 1, 2, 3, 4. After first swap only, we became 1, 2, 3, 4, 7. After that, when we do compare, there is no swap, no swap, no swap, right? We don't go with the last one. So since no swap happened, let's not go to rest of the passes. So we need to flag this with a boolean so that we can stop our sorting algorithm at this point and already declare that it is sorted. Okay. So there should be a way to break our loop. So let's do it. Okay. When we enter the first loops, we'll create even outside this, we'll create a boolean flag, boolean swapped, if it has been swapped or not. By default they are false. Okay. So, but we'll rewrite them. Swapped is equal to false. Okay. At the beginning of each pass, we are marking our flag as false. Okay. Now if any swap takes place, so if it comes inside this condition a swap has taken place, we'll mark it swapped is equal to true. Now if end of the first loop we see that no swap had taken place, okay, that would mean if no elements were swapped in a loop, break. Okay, so we'll say if not swapped, break. Okay, now let's run it again. We won't see any effect here, but now it will not perform unnecessary comparison. So we did some optimization on this. Okay, I hope it helps. That's all. That's actually pretty much most of what we have in the bubble sort. But in the summary, on time complexity, the time complexity is O of n square. Of course, we have learned how to calculate time complexity. If you go here, it's already a for loop that is running 0 to n. Then again, we have a for loop that is dependent upon n and running from 0 till n. So it is for loop inside a for loop. It's O of n square. Space complexity O of 1, because bubble sort is an in-place sorting algorithm. If you see, we do not use any extra space apart from a temp variable, right? So it's a in-place bubble sort. So it's O of 1. Pros: simple to implement and understand, suitable for small data sets or when the array is nearly sorted. Cons: it is inefficient for large data sets because yes, the time complexity is O of n square. That is not very good. We do have algorithms in O of n log n time complexity. The time complexity is relatively high compared to more advanced algorithms like quicksort and merge sort. Okay. So I hope bubble sort was clear to everyone. In case of any doubts, please let me know in the comment section. In the end, thank you very much. Please like, share and subscribe.